All right, I hope we are live, guys. Just confirm once in the chat section. Can you guys hear me and see my screen? I'll pop out the chat. Yeah, all right. So, hey everyone, I have a new announcement today. We have a new sponsor thanks to Coding Ninjas. But more important than that, I think we have a really good product when it comes to coding interviews. Uh, so, this is Code Studio by Coding Ninjas, and it's completely free. And they have a bunch of great resources over here. For example, they have a bunch of series of like top graph questions, top tree questions, and other than that, they also have like top Google coding interview questions. And this is what we are going to do today. So this is like everything that we will be doing is completely free. Anyone can sign up, and the link to that is displayed on the top right section of the screen, which is bit.ly/code studio free. Now, this product, Code Studio, is much more than that. Not only you can solve really good problems, I found the value, like the questions were of really good quality, and more importantly, they have around 2,000 plus coding interview questions on this, and none of them is logged. In a lot of platforms, we have seen that a lot of questions are blocked, and you have to pay for the premium price. Over here, as long as we have the free thing, I think it's better for us to take the advantage of that. And this is what we're going to do today. Moving on, like it is much more than just solving problems on data structures and algorithms. You also have guided paths, which is like really cool. You have guided paths on data structures, algorithms, competitive programming, DBMS, basics of C++, Python, operating system design, right? So these are some things which I feel that uh, students which are from other branches and not from computer science, they are often lacking in this. So this is like guided paths which is focused more on interview preparation. So you have like structured content. For SQL, you can see they have a bunch of different modules, and like you can, for operating systems also, you have a bunch of things, and you can also write SQL problems. Like you can write the SQL code and solve them. So if we'll just have a look at one, so you can actually write SQL queries and make progress, which is something which I found really good if you are talking about interview prep. Similarly, like they have a bunch of guided paths, even on system design, they have same, you can check that out. And the other good thing is the interview experiences that they have. Like they are first of all anonymous, as well as if you want, you can reveal your identity. So this adds authenticity. For example, if you talk about Walmart interview, I think this is like you can see the LinkedIn profile as well of the person who has shared the interview experience. And for all the 5 rounds, you're not just only having a look at what was asked, but you can actually solve the problem right away. So I feel that this is a good way to prepare. And again, to check out the complete product, you can go to bit.ly/code studio free. All right. So having said that, and thanks to Coding Ninjas again for sponsoring this live stream. Now let's start solving few coding interview problems. Uh, the difficulty is Ninja. I feel that this is really hard. So let's start with that. And again, like I'll let me just paste the link as well in the chat section once, so that everyone can access it. All right, cool. So let's start with our first problem, which is order of people heights. Let me also share the problem link with you guys. All right. So let's try to see. So average time to solve for this is 45 minutes. And okay, let's see. Let's switch to C++. What is the question? I'll just zoom in on the screen. So there are n people numbered from 0 to n minus 1 standing in a queue. You are given two arrays, the height and in front, consisting of n non-negative integers. Height I gives us the height of the ith person, and in front I gives us the number of persons who are taller than the ith person and standing in front of the ith person. Okay, and our task is to find out the actual order of people in a queue. You should print n integers where the ith integer is the height of the person who should be at the ith position from the start of the queue. All right. Okay. So let's go through an example just to understand this. So, okay, so there are t test cases and n is up to 10 to the power 4. And then these are the two arrays. The height can be up to, okay, who is such, I would love to meet someone with such a huge height. But okay, so this is the height and then this is in front. So for example, 5, 4, 3, 2, 1, I think this is what their example is. Okay, so there are six people. Their heights are given by the array 5, 3, 2, 6, 1, and 4. Okay, so this is the height. These are the heights, and then in front is this, right? Okay, so it's saying that the actual order of people's height in the queue will be this. This is the actual order because in this you can see that what does this do? It is saying that the person who is having height 2 has two people in front of him, right? So this is the in front one and this is the height. And similarly, this for 6, since it's the max, there would be no one who is taller than 6. So this will always obviously be 0. For 4, for example, it is saying that the number of people taller than 4 and in front of it are 2. So in this case, you can see that 6 and 5 are exactly the two people who are taller than 4 and in front of it. Similarly, for 3, we can see that only 5 is in front of him and 5 is taller. So for 3, we can see that it's 1. So we are given these two things and we have to find the correct order in which they're standing. All right. And it's saying that every person is having a different height and a valid order always exists. Okay, so we have to return the vector of int of heights and that should be in the correct order. All right. So based on the time constraints, I feel that the max we can do is n log n. We can't do something n square over here because we have test cases as well, and this is 10,000, so it's quite huge enough already. Okay, so this is a good question. Feels like something that Google can do. Okay, I'll switch to light theme mode. I actually do not. Yeah, this is much better, I believe. Someone is saying that what are the questions that small companies ask? I believe that they also have in the interview experiences. I believe they also have for other companies. Let me actually show you that. So this is Goldman, Walmart. These are big. I can understand that. But I have seen for other companies as well. So something like Dunzo is also there. You can go through the interview experience of Dunzo, for example. Or Zomato, like IPO has happened, so I wouldn't call it small, but I believe they also have for Zomato as well. So they do have for a bunch of companies, I think 700 plus interview experiences so far. Anyways, coming back to the question, let's just think, and I'll come back with water, and I'll be back in a minute. All right, I am back. So, okay. So how do we find the correct order, right? Do we have another example? Okay, so this one. So, okay, so everyone is okay. So this is descending order. So no one is tall. Okay. Mhm. All right. So there is no one. Okay. So the actual order will be 1, 2, 3, 4, 5, right? Yeah. Okay. So basically, think of it like this: that you are standing in a queue, and you have to answer how many people uh, are taller than you in your front, right? So you are standing in a queue. You can see only in the front, and you have to count the heads which you can see. So they should be taller than you. Okay, and that is given to us, and we have to generate the initial sequence. So in this case, it is saying that there are 5 people, and their heights are 5, 4, 3, 2, 1. And for every person, they are saying that there is no one who is taller than him. So it can only happen if everyone is standing in ascending order. So for 3, there is no one who is taller than him in front of him. Similarly, for 4, there is no one taller than 4 in front of it. Okay, so this is what we have to return given these two things, right? Okay. Um, I think the difficulty for this is Ninja, right? Which means it's really good. Um, okay, so how should we approach this, right? Um, so given this thing, what I can say, okay, there are 5 people, and um, okay, right. So we can say that who is the tallest. For that, the answer in the like it will always be a zero. Like there will be no one in front of him who is taller than the tallest. But it's not really helping me, right? Even over here for 6, you can see the in front is always 0 because 6 is the tallest, right? Um, but for example, for 3, yeah, this is something which can help us. So it's saying that for 3, okay, for 6 it's 0, that's fine. But for 5, okay, so this is helpful, right? For the tallest one, it will always be 0. But now for 5, which is the next largest, right? The next tallest, now this is 0. This means that 6 is coming after 5, which is true. In the correct answer, 6 is coming after 5 because this is 0. So in this way we can, so yeah, this is actually making sense, right? So I can actually figure out the answer. This is my attempt. So for 5, 0, I can say that since it's 0, it means that there is no one in front of 5 who is taller. So 6 has to come after 5. Now for 4 it is 2. It means that both 5 and 6 are coming before 4 because this is the next tallest guy, right? So it means 4 will come here, right? Had it been that this is 1, it means that 4 is coming either over here. Yeah, it's exactly coming over here. And if it was 0, it means 4 is coming over here. But since it's 2, it means that 4 has to come over here. Yep. Uh, this makes sense. Can I close this thing or maximize this? Okay. This is not helpful. Okay, I can write code over here. This is better. All right, so this makes sense. I'll actually, yeah, this is better. Okay. So as I'm saying, so this 5, 6, 4, because this is 2, it means both are coming before 4. Then the next is 3, it means 1. So it has to come after 5, right? It cannot come here, it cannot come here, right? And then we have, I think 2. So 2 is having 2, which means that it needs to be inserted after 5 and 3, which is over here. Uh, and then we have 1. Now 1 is coming at uh, like after the first 3 guys, so it is coming over here, right? And this is the exactly right. This is the exact order. Okay. So this is making sense, right? Um, Similarly over here, how would I do this? For this, I would say that uh, the largest is anyways, I can place it anywhere. Now the next largest is 4. It is saying 0. It has to come before 4, before 5. Now this will come again 0, so it has to come here, and then this has to come here, and then this has to come here. Something like this. So this makes sense, right? So I'm able to communicate the answer. Like this is another way to how we are going to implement this, but I think the approach is clear, right? I'll just wait for you to confirm the same. Is the question clear? And again, guys, we have a bunch of viewers, but the number of likes is really less. So make sure that you first hit the like stream. You like the live stream before we move forward. But I think the solution is pretty good. Um, so the largest we place it anywhere. Now we iterate in descending order of height, and while we are doing that, we exactly can place uh, wherever we have to place the current guy. So for five, we know that it can either come before six or after six. And based on their inferent values, we are deciding that. So think of it as a vector, initially with the tallest element, which was six. And now you have a vector. This was your vector or list, you can say. And now you're iterating in descending order of heights. And whatever height you have, whatever in front is this, it's basically insert your element 5 in your vector at this position. So you want to insert at 0 index, which means before, so this will shift over here and 5 comes here. And then 4 is coming at 2, which means that this is going all the way to the end. So the implementation can be a bit tricky, but the logic is pretty much clear to us. It's another problem how to implement this. So basically, given a vector, I want to insert things randomly in between, which is a bit problematic. Okay. Anyone having any ideas in the chat? All right. So I think the approach is clear. But the implementation is not that clear to me, and time is running. So let me speed this up. Um, so for the tallest, okay. Um, right. Okay. So I'm having a bit of trouble time in the sense that we have a vector, and since every operation should be at max login, how do I handle a scenario that I have a list and then I want to insert something in between at some index, and that in login time? That is a bit tricky for me right now. So um, I think okay, right. I have some idea. What I'm planning is instead of going that way, we can start with the smallest one, right? Um, for example, for one, right, that can also be done. So for one, it is saying three. Okay, right. Yeah. I think I got it. This is better. So we have how many? Six people. So six spaces, right? Available spots, right? Now I'm talking about the smallest person. For the smallest person, it's saying that there are three people in front of it, right? Isn't the position of one already fixed? One will always come here, right? The position of smallest element is always getting fixed because everyone would be taller than the smallest person. And if it is 3, it is exactly telling me the index. So this is zero-based indexing, 0, 1, 2, and 3. So it exactly told me the index. And now we move on to the next smallest person, which is 2, right? Now again, 1 is already smaller. So we have processed that, no problem over there. Now for 2, it is saying there are 2 people who are smaller than 2. It means that 2 has to come over here, right? Because if you place 2 over here, for example, these 3 guys will always be taller than 2, right? So the in front constraint asks us to fill the 2 over here, and then we move to the next taller guy, which is 3. It is saying 1. So 3 has to come over here, and then 4. Now 4, it is saying 2, right? So basically these two spots will be for the other two people, and then 4 will come over here, right? So basically we have a fixed size array that we are going to return, and then the question is um, I want to insert a number at the next available spot, right? So in this case, if we want to insert 4, what it is saying is insert 4 after 2 places, right? So first spot is this, then 3 are filled, then this is also filled, and then this is the place where we can insert 4. So this is what it is. So insert a number after x free spots, right? This is what we have to do. Okay, which I think can be done, but I'm going to use advanced C++, like I'm going to use policy-based data structures. Uh, so just bear with me. What I'm going to do is quite easy. Like I'm going to have a set, but a ordered set, which has additional capabilities than what normal set provides. So initially it will be having all the spots 0, 1, 2, 3 up to n minus 1. And what I'm going to ask him is, uh, so whenever I insert some number at some spot, I'm going to remove that from the available spot, right? So I always have a spot of blank. I only have indices of blank spots, and I want to get the ith element in that. This is exactly what the question is about. So this is exactly what an ordered set does. We will add it later on. Let's say we already have that. So what I'm going to do is int n is height.size, and I can say that I need to iterate in. Okay, so let's make vector of pair of int comma int of persons, and then oops, and then I can say something like for int I is 0, I is less than n, I plus plus. I can say that okay, so I also need an ordered set, um, free spaces, right, or free slots, let's call it. Initially, everything will be free, right? So let's insert each slot as a free slot. Anyone can sit anywhere right now, right? And also like persons dot push underscore back the current height of the person, and then in front. So once I have that, what I can do is I can iterate on person now. So I'm iterating on persons, and what I want to do is, um, okay, let's see, we have int height of the person, or let's call it h, person dot first, and then in front, right? So let's call it um, index for now, right? Because this is essentially the index of that person. That would be person dot second. And now what I am going to do is I'm going to ask my free slots that give me the location um, dot. I think the syntax is order, me find by order, right? Find by order index. So think of it like this. It's a list, and I'm asking the free slot that I want the fourth available spot or fifth available spot. And this is zero based. So essentially, I do not need to do plus or minus one over here. It will just work out of the way. And it will give me access to the next available spot. And now I want to remove that. So free slots dot erase IT. And before that, I am going to set or insert. Okay, so I need an answer. So answer of star IT is the current height. And I can return the answer. And answer is vector int answer. Initially it's empty. So this is what I'm having in mind. Uh, so this is something that normal C++ set does not give us, which I will be using policy-based data structures for that. I already have a video on this, but I think it's available in 𝗏𝗧𝗘𝗥𝗓𝗏. So let me copy paste the syntax to make sure that this works fine. All right. So let me include this. Okay. What else? I don't think this is the one. So this was an ordered set kind of thing, right? Yeah, this one. Okay. So I think let me just zoom out once, guys. Ordered set we have now. Yep, this looks, let's run the code and see if it works. Okay, so some errors over here, right? Um, okay, I think there is one more. This. Uh, so if this was a real interview, I would have just asked that. Okay, so we still have some error. I'm not sure what is the error right now. So if this was a real coding interview, I would have just asked them that this is like, I'm assuming that we already have this library built. If not, then that's a separate question, how to build this ordered set. But I'm assuming we already have exposure to that. Anyways, I don't think this is working. Let me just check a working example once. I remember that this is the article, but maybe I'm. Yeah, we also need using namespaces. I don't think we have added that. Okay, let's also add that. Hopefully this will solve the issue. All right, so it's fine. We have made some progress. We are getting some runtime error. That's fine. Let's have a look at the code and try to see if we are making any mistake. Okay, so I have not sorted the persons. That's one thing. So sort persons dot begin and persons dot end. So that's one thing. And let's see if this fixes this. Okay. All right, let's see where's the problem. So in the free slots, I'm making sure that from 0 to n minus 1, everything is being inserted. I'm pushing the current person height and in front in the array. I'm sorting it, makes sense. I'm iterating on the person. I'm taking their index. Okay, this makes sense. I'm finding by order the free slot. This is a pointer, so I can later on erase it. Before erasing, I am, okay, so this should be n comma 0, and this should work now. Yep, correct answers. Let's submit this. Time limit exceeded. Come on. This is n login, guys. What can I do better than that? Score is 90, right? It's not 0. Oh, it got accepted. All right. Maybe we were on just on the brim of getting time limit exceeded. But yeah, this is one of the possible solutions. But again, if this had been a real coding interview, I would have just asked that. I'm assuming we already have this ordered set built. And essentially, this helped me, right? I was able to write the major chunk of code. And even if I did not have enough time to write this syntax, it's still fine. Instead of, first trying to implement this data structure, or that changes the intent of what the interviewer was trying to judge you for. So it's always good to first just write the main crux or the main algo and then complete the other dependencies that you have. So hopefully this makes sense. I have to sort, right? Otherwise, the order will be incorrect. When I'm removing something in between and then I'm asking the fifth available slot, so that's important. The order is important. All right, I love the problem. I hope you also like this problem. Let's move on to the next one now. Again, the problem link has been shared with you guys. I'll also paste it in the Discord. So this was our first problem. I pasted it. And now let's try to solve the next problem, which is maximum distance. So the difficulty is easy, and 10 minutes, I think that's good enough for us. Uh, for Google interviews, especially, there is another tip that I would like to give, which is if you're interviewing with Google, generally the time for their interviews is 45 minutes, in which they also, kind of explain the problem. Then you share your approach, then you finalize your approach with the interviewer. They give you a heads up that, okay, this sounds good. Or if not, they have a discussion with you that you're going wrong and probably, do something else. So you have all these discussions and only then you move forward. So be really fast when you're writing code, especially when you're talking about Google, because 45 minutes is really less for that much to happen. So when you're writing code, just be really fast. Uh, and even when you're approaching or sharing something, don't start with like a very long story of some brute force and then slowly and slowly in multiple approaches you're moving, making progress. Don't do that. You have limited time. It's really good to show some speed over here. All right. The problem statement is really small, so that's good. And anyone is having any uh, great implementation? Thanks. All right. Okay. All right. Let's move on. So we have an array of integers, which is pretty much obvious from the signature of the function that we have. And now we have to find the maximum value of j minus I subjected to the constraint of ai is less than equal to aj, where I and j are the indices of the array. Okay. Okay. So basically over here, answer will be 2, correct? Because 3 and 4 is the pair, which is, so basically we want the pair which is as far as possible with the constraint that the element which is on the right side, it's greater than or equal to the current element on the left side. Okay. All right. Before we move forward, I think there is one other thing that I also want to mention. Over here, not only you, like, I think the quality of problems is really good, but the other good thing is, let me see. Yeah, so they also have solutions, right? Um, and they have multiple approaches. Like they will start with a brute force way, which you can understand. Um, Let me just refresh this. So basically, they have multiple approaches, and for each approach, they also show the solution, which is something which I really liked. They have a walkthrough of the approach as well as the code on the right side. You can see the code is also in multiple languages. C++, Python, and Java, both are, all the three are supported. And approach 2 is also there, approach 3 is also there. And okay, so they are using segment trees to do this. Exactly. They are also doing the same thing. They are finding the kth empty slot. I think I also had another solution initially, which I told, right? Like start with the max and then go in descending order, which was another approach. However, I use the policy-based data structure to make my life easy. Segment trees is another way, and you can have a look at the code if you want. All right, so I have completed that. Let's close this. Okay. So the brute force way is pretty much clear, right? Order n square group. For every pair, we check that the constraint of AI and AJ is met, and if it does, we do the maximization of the answer. That's the brute force way. But the constraints, okay, 100 test cases, again, like 10 to the power 6, which means at max and log n. And numbers can be negative. All right. Okay. Uh, so we want the pair which is as far as possible, and at the same time, AJ should be greater than or equal to, right? Right. Okay. So so this is not easy for me. I wouldn't categorize this as easy. I think it's a good problem. And what I'm trying to do is, for example, if it's 3, 5, 4, and 1, what I'm going to do essentially is I'm going to iterate from left to right, which is the standard way of iterating. And when so whenever I reach some index I, or let's call it j actually. So whenever I'm at j, I have iterated all the necessary i's, which I'm going to maintain another array. So this is another array. And over here, I am storing. So for example, this is like the index array. And what it is telling me, for example, over here, we see 10. So at index 10 of index array, right? I'm going to let's call this as the 10th index. I'm going to store 1. So index array is basically telling me, and then if this was, let's say 2, I'm going to say that index array of 2 is 0, right? So this is what I'm planning to do. And how is this going to help me? Well, this is going to help me in this way. Whenever I read j, and let's say j, the current number is, let's say 7, right? So for 7, I can actually, so okay, let me update this. So over 2, we had 0, right? So now what I want to do is, when I come to j, I can say that, okay, right. So j, the current number is 7. What I can do is I can check the 7th index and everything beyond that. And over here, I need to take the minima. Oh, sorry. I need to take the minima in the prefix, because this is j, right? And all the I values that I have processed, the index was already less than j because I'm iterating from left to right. So this part of the constraint is valid, that I is less than j. However, to verify ai is also less than j, what I'm going to enforce is the current aj is 7. So I'm only going to take the minimum from the first index up to 7, because this is all the numbers below 7 or less than equal to 7, and I'm going to take a minima, right? This is my plan. I'm going to take the minima of the prefix, and I can probably do that using Fenwick trees. Um, and for every possible j, I can find the minimum ai, because to maximize j minus I need to find the minimum I, right? And the index array is containing indices. So I find the minimum I in the range 0 to aj. So this is the benefit of index array. I hope that clears things up. Let me know in chat once. Anyone is having any doubts, just let me know once. So I hope this is clarifying, right? For every number, I'm updating the index array with the actual indice value. So this is saying that 10 is coming at indice 1. And when I do that, whenever I read some j, what I'm going to do is, for a, so the current aj is 7. So I will take the first 7 indices and I will take the minimum I from that. And this operation I'm doing in auto login using BIT or Fenwick trees. So for every j, I can find in order login time what is the best I that I can take, and so on, so forth. I'm going to move on. So yeah, this is my idea. Just I'll give you a minute or two, and I'll drink water, and I'll be back. Alright guys, I am back. Anyone is having any doubts? Yes, AI can be negative. For that, we can do one thing since the numbers are up to, I guess, 10 to the power 5, we can actually um, add 10 to the power 5 in everything just to have it. So that's a good point. What I'm saying is for int and x in A, I can say x plus equal to shift, or over here we can say. So after this, every number would be possible, but that's a good point. So this is 10 to the power 5. So everything is possible now, and over here, what I can do is um, I can move forward, and I think my video is off. Let me turn that on. Right. So as I was saying, I'm iterating on the j values, and actually we can start from one. And over here, we need some bit. Let's say that it's not at position. Like I've forgotten how BITs work, so just give me a sec. I think that we should not use zero-based indexing. So let's say we are using one-based indexing, and a of 0 is the first number that we insert. And now let's move forward with the next numbers. So the current number is a of j, and the current index is j plus 1 because you're using one-based indexing. So it's better to you know step that complexity away in other variables. So the current number, its current index is this, and now what I want is to find the smallest I such that a of I is less than or equal to 1. This is what I want to do. For which I'm going to query my BIT, and what I'm going to do is I'm going to send a curve over here. This is what I'm going to send, and over here I think it should be the other way around. We are going to say, um, yeah, this is better. Correct. We do not need one base index. My bad. We do not need this. So you're going to query the BIT to get the smallest I. Then answer is max of answer comma j minus 1, something like that. And then we are going to update or insert the BIT, the current number, and okay, at this index, yeah. So at the current index, we want to insert the. So basically, this was index array, right? When we had 10 over here, we went to the 10th index to insert 1. So it's kind of a reverse, right? Over here, index 1 and value 10. Over here, index 10 and value 1. So it's kind of a reverse. So this is the index. So just to make sure, void insert int index and int val. This is what we have to implement. I haven't done that yet. I will do it in a while. So insert the current at the current index, the current C. And initially we should keep, I think, everything as int underscore max because we are going to take the min, right? So initially everything should be max. And const int n is, let's say, 2e5 plus 3. So we have a int dit, and initially what we are going to do is, uh, let's say for int I is 0, I is less than n, I plus plus. I'm going to say bit of I is int underscore max. And now over here, I've forgotten the syntax to be honest. How did it work? So, so while index is less than n, so I need n. I want to do something right. I think its bit of index is, I guess, minimum of bit index on that, right? And then am I forgetting things, right? And then the next index was, I think, uh, f of index, and f of index is hash define f x x and minus x. I'm not sure about the syntax. I might be making a bit of mistakes of it, but I guess it was something like this. I think this is correct. Let's see. For query, we want something like this, and index, and over here, um, while index is positive, we want initially answer can be int underscore max. Then we can say that answer is minimum of answer. So finding the smallest line, right, in the prefix, and then we can say index minus equal f of index, and over here the index. I think so. This should work. Return answer. Well, and over here I can say return answer, and I can comment everything over here. I'm not sure if this syntax is correct. I'm writing code for NVIDIA or BIT after a long time, so I might be making mistakes. Okay, so C++ syntax, this thing is not supported yet, I guess. Int underscore max was not declared. Okay, so let me include everything. Bits standard C++.h. But I think it is something like this. I feel so. I made a typo. Okay, what else? Answer is not declared. Come on. Answer is 0. No, this is amazing. Now, if I get this correct, I believe that. Um, hey, we got a score of 90. I believe that if we run it again, it's just going to work. We are having really edge case scenarios of time limit, I believe. Even if it doesn't, I'm not sure. Okay, so it's time limit exceeded. We have a score of 90, right? Okay, so 10 test cases passed, one is given time limit. Damn it. Uh, I think n can be made a bit smaller over here. And then when we are doing this, okay, how do I handle the negative values? Yeah, I think we can do coordinate compression. So this can be 1e5, and hopefully we will save some time. So, um, so what I'm going to do is I'm going to find the minimum. Okay, I don't need that. I can do coordinate compression, guys. So just bear with me for a minute. I can say that coordinate compress A, and this is going to take care of that. So what essentially I'm going to do is at max we can have n values, right? So I'm going to change. Um, so I'm going to change. Just let me type once. So I'm going to change the array elements because in this question the values exactly do not matter. It's just the order matters. So if I'm having 1 and then 100 or something like this, I will actually convert this thing into 1, 3, and 2. The answer for both these vectors will be same. So instead of going all the way up to here, I'm just saving myself some space. So for that, I can have a map of end to end, and let's use an order map just to save more time. So an order map end to end, let's call it ID, and the end counter is 0. And then what we can do is we cannot. So we need to copy this. Yeah. Actually, let's do this that we return that, right? So let's vector int. Yeah, this is better. So now I'm going to sort the array. I guess I need to store original array once. So vector int original is A. Now I can play around with that. So I can sort the array. Or if I do not want that, actually I do need it. Yeah, so let's sort it out, right? Once I've done that, what I can do is for int x in A, I can say that ID of x is uh, plus plus counter ID, and then I can say that okay, for int and x in A, x is nothing but ID of x. So I'm doing coordinate compression over here, and since this is ampersand, I'm actually changing the value, and this should actually speed things up. Just making sure that everything is working. So let me run the code once. Oh, I'm not returning anything. So return. Yeah, that's fine. I have to return something. I have to return A. Wait, I in original. Sorry, and then return original. All right. Let's see if this works. Yeah. Now let's try to submit. I'm not really sure what else can I do over here. This is nlogin, clear cut nlogin. I'm not sure what else should we do. Is there some test case that we are missing, something like that? Uh, I think this should work. Anyone is having any ideas? So you're having audio issue. Just let me fix that. I hope it's better now. Is it better? And let me also share the problem link, guys. Just a sec. The link to the second problem is pasted over here as well as on the Discord. All right. I'm really not sure what edge case am I missing. From the looks of it, I'm happy that I'm able to solve or get a score of 90 because I believe that I am writing code for 𝗫𝗥𝗡𝗣 after a long time. Um, Not really sure why is it getting TLE. Let's see the solution if it helps. Oh, so they're doing it in order n time. That's great. The idea behind this approach is to create a monotonously decreasing array and comparing its values to the given array to find maximum distance. Okay, so we have the code. Let's have a look at the code and try to understand it. Oh, this is a small good solution. Let's see what it's doing. And my video is off again. All right. So we have a vector r max. I'm hoping it's like a suffix kind of thing. Yeah. So it's a suffix max. Okay. Okay. So this is just telling us the max greatest value, right? How is it going to help us? Okay. So this is something different, I believe. This I got. R max J is telling us the max from the current jth to the end of the array. that is what Rmax is about. Now it is having two pointers, I and j, which are 0 and diff is -1. It is saying that if, okay, if AI is less than or equal to Rmax, which will be true, um, it is saying diff is and j is j plus 1. Else move a step ahead. Why is it order n is my question. So in each, okay, so in each loop, either this increments or this increments. So this is definitely order n. And we, as soon as something reaches n, we break. So this is order n. How is it working? Initially, I and j was 0, right? And we compared A0 with Rmax 0. Rmax 0 will obviously be greater than equal to this. So j moves on forward. And it goes on up to a point after which everything is smaller than AI, right? So this will keep on happening up to the point after which everything beyond that point is smaller than the current number. And at that point of time, it is incrementing I. Okay. Ah, I see. I see. I see. So we were having I and we were having J. It is saying that we already have this much gap available. Now, what it is saying is if you are moving one step forward, it only makes sense to search for the remaining J in the remaining space. Something like that. Yeah, something like that. I hope it's making sense, right? So essentially, when you're talking about A0, it will keep on moving forward. It will keep on moving forward up to the J, after which every number beyond J is smaller than A0. So this is one, like, the you are at the best case scenario for A0. Now what it is saying is, if you are over here, now when I'm incrementing I do not need to consider all these j values because I want to maximize my j minus I. So I'm only going to search in the remaining space and I'm going to go as max as possible. And then I'm going to increment my I again. Okay, this makes sense. This is R max, correct. This is a cool way. I did not think of it. All right, I think I learned something, and I hope this makes sense. My solution was a bit complex in this because, and that is why I was saying that why is it tagged as easy? But again, I would tag it as a medium problem. But this one was like this came to me naturally, maybe because I have done a lot of competitive programming, and n log n is not that bad. But again, the best case scenario is this, which I did not know. Um, all right, guys, that's pretty much about today's stream. I hope you liked this platform. Again, like to sign up on this, everything that we will cover in this live series will be free. So this is the link which is blinking on the screen. You can just have a look. And I hope you like this platform. And thanks for joining the stream today. If you are having any doubts, just let me know in the comments and we can end the stream after that. All right. Anyone is having any doubts, just let me know. Thanks. Anyone, any questions? All right, I guess that's pretty much about it. I hope you enjoyed solving these two problems. I feel that the difficulty level was quite good over here. And I hope